Okay, so we're picking up on the second video in this solving rational equation repeat lesson, just so it'll give you something to kind of hang your hat on when you go home and you're trying your homework. So in the next example, we have an LCD. So remember, what we're going to do is we're going to solve by using the LCD. So we're multiplying each term by the LCD to eliminate the denominators. So in the first few examples, I'm going to show you how you're looking for the LCD, which is obviously 2 and x are the two factors, so it's 2x. And you multiply by the missing factor of the LCD. So you can see that when I do that, I get a 6 over 2x, and then minus, then I have an x over 2x, and then that's equal to 24 over 2x. Now sometimes there's a tendency, there's a tendency to say, oh, 2 goes into 24. But what you're trying to do here now is you want to eliminate the denominator. So when you do this, you're going to take the left-hand side, you're going to multiply by 2x. Now you're again going to say x cannot equal 0 because it's in the denominator. So that's the only restriction on the variable. So if we happen to get 0 for an answer, then it's not really an answer. And then we're going to take the right-hand side and we're going to multiply that by 2x. Okay, so then when we do that, the equation becomes very simple, right? We're just going to get this. We're going to get as we distribute, we're just going to get 2x times 6 over 2x. And sometimes this is good to kind of see this. And I'll tell you, sometimes what I do is I squeegee in a 2x by each term. We're going to do that in one of the examples. So the denominators go away. So you're left with 6 minus x is equal to, then it's just going to be 24. So when you solve this, 6 minus x is equal to 24, you can add x to both sides and subtract 24 from both sides. Add x here. So we get x on the right-hand side, then we get 6 minus 24, which is negative 18. So x is equal to negative 18 and not a constraint, not a value that we have to worry about. So we're good to go. There's your solution. Okay, and if you check it out, 3 over negative 18 is going to be then negative 1/6, right? Negative 1/6 minus 1/2. So that has to be 12 over then negative 18. So 12 over negative 18 has to be equal to negative 1/6 minus 1/12. And you can do the math and it checks out. Okay, all right, on the next one, there's only a 4 that doesn't have a denominator on. The LCD is x plus 1. So we're going to then multiply a 4 by x plus 1 over x plus 1. So then that will give us what we need. So I just have to juice up my pen just a second. And you can kind of see with the 5 over x plus 1 equal, when I highlight those terms, it's because that's the original equation. So we're only multiplying the 4 by x plus 1 over x plus 1. Let me see if this will get it going. Okay, so we have 5 over x plus 1 is then equal to 4x plus 4 minus a 5, and then that's over x plus 1. So you can see that if we take both sides of the equation and we multiply by x plus 1, I'm just going to put it in here, and we're going to multiply the right-hand side by x plus 1. Essentially what happens is that the x plus 1s will then cancel with each other. They are common factors. So now we can simplify easily. We go from here to here, and we have 5 is equal to 4x minus 1. Add 1 to both sides, and we get 6 is equal to 4x. And dividing both sides by 4, you can see we're nearing our answer. X is equal to 6 over 4, or 3/2. Okay. 6 over 4, or we get x is equal to 3/2. I kind of changed sides of the equation. Now, the only restriction on this equation is that x cannot be negative 1. So that's not a problem. We get our solution here, 3/2, okay? Now, I do this with, I want you to pause your video and pick up on the next video and try these two equations where we get the LCD, and then after we get the LCD, we multiply each term with the missing factor of the LCD. But remember, first we have to factor in that second one, all right? Okay, thank you very much.